Okay, so Darren bends a piece of wire using a circular disc to make the shape as shown. How long is the wire from here to here is basically what they're asking. How are we going to figure that out? Well, if we wrap it all the way around the little disc, then what would that be? What's that called when you measure the outer edge of a circle? Circumference. Now, this is just part of the circumference. How much of the circumference is this? A fourth of it, because there's 90 degrees here out of 360 degrees, which is a fourth of the circumference, right? So it's a fourth of the circumference is 2 pi r. Well, we know the radius is 22, right? So it's 1/4 of 2 times pi times 22. So 4 goes into 2, 1 and 2 times, and 2 goes into 22, 1 and 11 times. So it's 11 pi or 30, I don't know, 34 point something something. Somebody on your calculator, take 11 times pi. 34.56 round to the nearest hundredth centimeters. That's how much wire is wrapped around from there to there. So the whole piece of wire would be 134.56 centimeters long. Okay? So when we're working with arcs, there's major arcs and minor arcs. A major arc is over 180 degrees. A minor arc is less than 180 degrees. So JM here is a minor arc. Let's say the angle inside of here was 130 degrees. Okay? Then the measure of arc JM would be 130 degrees. The measure of an arc is the same as the central angle. Okay? And let's say that this angle here is 40 degrees. How big is JK out here? 40 degrees. How big is KL? 40 degrees. So that makes this angle 40 degrees. Okay? So, a major arc is greater than 180 degrees and uses 3 letters to name it. A minor arc is less than 180 degrees and uses 2 letters to name it. Okay? So, I want to know how big arc AB is and how big arc ACB is. Well, AB is a minor arc here that goes from here to here. How big would that be? 95, because it's the same as the central angle. How big is arc ACB, the one that goes around here? Well, there's 360 degrees in a circle. If 95 are used right here, what's left for here? 265. So this is 265 and this is 95. Okay? How big is XZ in this case? 115. How big is XYZ? 245. Okay. So, an arc length is what we started with today. An arc length is a fraction of the circumference. So whatever that angle is out here, it's a fraction of 360. So if we're figuring out how long that arc is, that's different than the angle that it takes up. Okay? So the arc length depends on the radius of the circle and the arc measure. So the arc length is divided by the circumference equals the arc measure divided by 360, or we follow this formula. Arc length, and arc length is S. Arc length is S. Arc length equals an angle divided by 360 degrees times 2 pi r. Okay? And that formula is right up here. The geometry arc length formula. So that'll be on the board. The angle divided by 360 degrees times 2 pi r. That's if it's in degrees. But sometimes we measure in radians. And what is a radian? A radian is equal to the measure of the central angle that intercepts an arc with a length equal to the radius of the circle. So, if this radius is 4 and this arc length is 4, then the measure of the angle would be 1 radian. If the radius is the same as the arc length out here, then the angle in here is 1 radian. Now, a circle can be 2.68-ish radians. Exactly, it is 2 pi radians. 2 pi is the number of radians in a circle. Okay? 2 pi radians is the number of radians in a circle. So, what happens is when we use the formula, our 2 pi's cancel, and so when we're in radian measure, we take the angle times the radius. The angle in radians times the radius, and that gives me the arc length. Now, most of the time you'll be finding arc length using degrees. But if you're given radians, that's a super simple formula. Just take the how many radians it is times the radius, you find the arc length. Okay? So those are our two formulas. If you're in degrees, it's that formula. If you're in radians, it's that formula. So the radius here is 4. We want to know the length from A to D. Now, this is in degrees, right? So you take 73 plus 43, which is 116, plus 104 is 220 degrees. Divide that by 360 degrees and take that times 2 times pi times the radius, 4. Now, this is where you use your calculators. Okay? Take 220 divided by 360 and take it times 2 and times 4. but do not take it times pi because we want the answer in terms of pi. And you're going to get some wacky decimal, right? Are you going to get some wacky decimal? 4.8 repeating. And let's say the computer says write as a fraction or a whole number. Then what are you going to do? Well, you got to tell your calculator to write it as a fraction. So instead of doing the divided by, you're going to hit 220 and then your A, B over C button, your fraction button, and then 360, and then times 2 times 4, and it's going to give you a mixed number, right? So then you're going to push second and then AB over C. And then it'll give you an improper fraction. What's your improper fraction now? So your answer you type into the computer is 44 pi over 9. Okay, 44 pi over 9. Because that's what that crazy decimal and the fraction, because you must have had what, 4 and 8/9 or whatever. Okay. This one is in terms of radians. Radians are a little bit easier to deal with. What is the length of JK? Well, you just take 3/4 pi times the radius, 5. What's 5 times 3? So it's 15 pi over 4. Easy peasy lemon squeezy. Now, if we want to find HK, we have to add up 1/3 pi plus 3/4 pi. Well, 1/3 and 3/4 your calculator can handle really easily. Okay? But if we do it without a calculator, what's the common denominator between 3 and 4? 12. This is 4 out of 12 plus 9 out of 12 is 13 pi over 12. So we're going to take 13 pi over 12 times 5. Well, 13 times 5 is 65. So 65 pi over 12. There we are. Okay? That's arc length now. Okay? All right. We know YRZ is 94. ZRW is 63. We know the radius is 7. How do we find the arc length of WZY? Well, what do we do with these two numbers? Add them up. 63 and 94 is 157 over 360 times 2 pi times 7. We want our answers in terms of pi most of the time with the computer. So you take 157 AB over C, 360, times 2 times 7. And then if that's bigger, which it is, if it gives you a mixed number, then you push second AB over C. What's our final answer? 1099 and throw the pi on in the end. 1099 pi over 180. Okay, the next concept that we're going to do is the sector of the circle. That's the region bounded by two radii and the intercepted arc. So basically, you're finding the area of a pie slice. The area of a slice of pie or a pizza or whatever, a slice of pizza. You're finding the area of a certain amount, certain shape there. So we go about this kind of the same way. If we were finding the area of the circle, it'd be pi r squared, right? But we're only finding the area of part of the circle. How much of the circle? Well, however much out of 360. So in this case, we're finding 78 degrees out of 360 times pi 10 squared. Well, I know 10 squared is 100. 100 times 78 is 7,800. Now you just reduce that fraction. So it's 7,800 AB over C, 360. And then it gives you a mixed number. Change it to an improper fraction. What does it give you? Something bigger than 20, I think. So, what? 65 over 3 pi. Okay. How do you find the area of this sector? How do we set it up? Area equals 165 over 360 times pi times 3 squared. So take 9 times 165 and then divide that. Well, not divide that, but first take 9 times 165, press equals, and then hit the AB over C over 360. I think that's what you'd do. And then see if it'll work it out for you. Does it give you a fraction? So what's your fraction? What did you get, Evie? 4 1/8. So that would be 33 pi over 8. 33 over 8. Okay. I'm going to skip this one because we've done 2 in a row like that. You kind of know the basics of it. Okay, the segment of the circle is the part of the arc and the segment joining the endpoints. Okay, so now we're on to the segment of a circle. All right. So I'm trying to find this little sliver of a piece right in there. Okay, that area. Now, we just figured out how to find the area of a sector that looks like that. We know how to find the area of a triangle that looks like this. How do I find this little sliver? What would you do to find that little sliver? If I know how to find this area and this area, how would you find this sliver? You would subtract these two. Take the area of the sector minus this area, and it just leaves you with that area, right? So we're going to subtract. So the area of the sector is 60 over 360 times 2, or times pi times 8 squared. Okay? So I don't know what that is just off the top of my head. What's the... Oh, actually, and then what did you get? 32 pi over 3, right? Now take that times pi, so we get a decimal answer. So take 32 times pi divided by 3. What? I'll go with that. Okay, now we got to find the area of the triangle. Area of a triangle is 1/2 the base times the height, but we don't know base and height, so we go 1/2 of one side of an angle times the other side of an angle, because these are both 8, times the sine of the angle in between. Okay? So 1/2 of 8 times the sine of 60. 1/2 of 8 times the sine of 60. It's going to be a little less than 33.5. 27.7. So if we subtract these two, we get 5.8. And that's the area of the little sliver in between. Okay? Let's do that one more time, and then we'll go on to a couple more problems, and then I'll let you get going on your assignment. Okay, this sliver, okay, we have to find the area of the sector, which is 90 over 360 times pi r squared. Well, 90 over 360 is 1/4 times 100 pi, or 25 pi. But we really need a decimal here. What's a decimal for 25 pi? Should be like 78 point something something. 78 point what? 54, something like that. Yep. Okay. Now the area of the triangle is 1/2 of 10 times 10, because these are both 10, times the sine of the angle in between, which is 90. 10 times 10 is 100. Half of 100 is 50 times the sine of 90. 50 times the sine of 90 is 50. So if we subtract these, we get 28.54 feet squared. Okay? That's how to find the area of a segment. Okay, so we're going to skip over that one and look at Chen's artwork. Chen uses circular corkboard to make 18 watermelon coasters to sell at a craft fair. He paints one side of each coaster with special paint. Each jar of paint covers 200 square inches. Will one jar of paint be enough to cover all the 18 coasters that he has? Well, to do this, are we finding arc length or sector area? Sector area, because he's painting it. He's covering an area. So it's 72 over 360 times pi times the radius squared. Well, if the diameter is 8, what's the radius? 4 squared. So take 72 divided by 360, and then because we're having an answer that's not in terms of pi, because we need to know numbers wise, multiply by pi and then times 16. So 72 over 360 times pi times 16. What do we get? What do we get, Dylan? 10.1. Okay. Now, if there's 18 of them, we multiply 10.1 times 18. And I get 180 what? 181.9-ish? Something like that. Is that less than 200? 180.9? Okay. Okay. Is that less than 200? Yeah, so yes, one jar of paint will be able to cover it. Then what he's going to do is he's going to take these watermelons and put some kind of cute tape on each side. Okay? How much tape does he need for each of them? Well, how long's this side of the coaster going to be? Well, what's the radius of the coaster? 4. And this side's going to be 4. We just have to figure out the length of this side. What's the length of this side called? The arc length. So the arc length equals 72 over 360 times 2 pi times 4. Figure out that as a decimal number. So you're multiplying by pi. So 72 over 360 times 2 times pi times 4. What do you get as a decimal? 5.03. So let's just call it 5. 4 plus 4 plus 5 is 13 inches of tape per thing. And if he needs to make 18 of it, you multiply 13 times 18. What's 13 times 18? So he needs 234 inches of tape. Okay, so this is everything we learned today. Okay, that's everything we learned today. Sector area, arc length, segment area. And so out on Savvis Realize or out on Google Classroom, you can get to your homework.